Hello everyone and welcome to the NPTEL session on pharmacognosy and phytochemistry. This week we are learning on a set of protective yet vivid and colorful compounds, and those are flavonoids. In this session we will be learning about few more flavonoid containing drugs. So in this session we will be learning about soybean, milk thistle, grape peel, and their applications. To start with, let's discuss soybean. Now soybean is something in Indian population, we have it in our meal, we have it in our flour, and we use it almost on a day-to-day basis in some households. So soybean consists of actually the seeds which are obtained from domesticated species of Glycine max. Now Glycine max is the cultivated and domesticated species which have been obtained from Glycine soja. Glycine soja is the original, or what we call as the wild species, and both of them belong to the family Fabaceae. They bear pods or leguminous pods, and inside this leguminous pods are located the seeds. So soybean, if you see, generally is sown during the monsoon season wherein it grows, and in Indian conditions you can take advantage of the monsoon, and towards the end of the rainy season, towards almost like September, October, you will see the crop is ready. It will start flowering and then it bears pods. You can see the soybean pod in the image. As the pod ages, you will see that the green color fades to a little yellow and thereafter brown. So once this is done, the crop is harvested, it's allowed to dry and threshed. On threshing or on beating, you will get those soybean seeds. These soybean seeds have been used in food and also used for numerous phytochemical compounds which have been isolated from it. Now geographically, Brazil, US, Argentina, China are producers or the leading producers of soybean, but yes, India also is gaining and we consume a lot of soybean. If you go to see soy based products, you will see that in Chinese and Japanese cuisine there is soy sauce, there is tofu. So a number of soy products have been used from these countries, and soy has also been cultivated in these countries as well. So soy, the beans are processed to extract oil, to extract protein. So let's see what chemical constituents it contains. So when you're talking about soybean, the chief compound of soy or the chief component of soy is soy protein. In fact, for those who are vegan, it is said that they take more of the soy milk or consume more of the soy chunks. Soy chunk is the residue which has been left after the oil is expressed from soybean. So this is a rich source of protein, especially for vegetarian population, and if you see this, the protein content may go as high as 60%. Now this protein chiefly contains two components. Now these two components, one of it is a hexameric protein called as glycinin with a huge molecular weight about 300 to 400 kilodalton, and another a globulin like trimeric protein which is your beta conglycinin. So glycinin and beta conglycinin are the main components, but in addition to that you have other protein components as well. Now some of these components also are responsible for giving allergies. Some people are allergic to soy products, and that is why this protein components and determination of the elements is vital. Now the fixed oil which has been obtained from expression of soybeans contains about linoleic acid, folic acid, palmitic acid, linolenic acid, and in unsaponifiable matter, it contains your plant sterols such as stigmasterol and sitosterol. But in the interest of this chapter, we will take our focus on the lesser compounds which are present in this plant but yet are very potent, and those are your soy isoflavones. So, the soy isoflavone compounds present in your soybean are your genistein, diadesin and glycitin. So, they remain in your soybean, and as a result, if you consume food rich in soy meal, apart from protein, you will also get this isoflavones. Now, why are these isoflavones important? Let's discuss their structures first. So, if you remember, isoflavones are the derivatives of flavonoids, wherein we saw your ring B is attached to ring C, but here instead of second place, it is attached at the third position. So, depending upon that, you have your genistein. Genistein is a 4-hydroxy, and in this case you will have 5,7. Typically flavonoids have a 5,7 dihydroxy pattern. The next flavonoid is diadesin. The diadesin misses this hydroxy. So, if you remove this hydroxy from the genistein, you get your diadesin. And the third component is glycitin. So, what happens is this hydroxy is missing in glycitin, but in addition you can add a methoxy derivative. So, you have your genistein, you have your diadesin which has hydroxy missing, and you have your glycitin which has the hydroxy missing, but methoxy in addition to your diadesin. So, these three in their native form and some of them in their glycosides, apart from other flavonoids which are present in minuscule quantities, make up the flavonoid composition of this plant. The focus here is these isoflavones are known as phytoestrogens. Why? So, if you see estradiol, okay, so the structure of estradiol, if I just kind of take the backbone which is vital for me, okay, you can see it alases and I can kind of overlap here. The substitutions may not be the same, but I am just talking about the backbone. Now, here there is a 5-membered ring, but here somewhere we fit in a 6-membered ring. Now, it is said that owing to this coincidence or owing to the resemblance to the structure, the isoflavones have a good ability to fit in the estrogen receptors. The work that they do is they act like a estrogen mimicking agents and hence are called as phytoestrogens. So, flavonoids, especially those belonging to the isoflavone category, act as phytoestrogens, and that is the reason soybean is vital. In fact, it is said that like the reason why incidences of cancer are so much less in Japan, one of the reason was found out that that especially the Japanese population having much of soy based diet was one of the responsible agents or one of the responsible causative things what was attributed to less incidences of cancer in the Japanese population. Apart from that, it also contains an emulsifying agent called as soya lecithin. Soya lecithin is something that gives you a silky smoothness to your chocolates and act as a very good emulsifying agent. Now, knowing this, where all we can use soybean. Now, because it is a estrogen mimicking agent, especially in menopausal women, it is known to protect, during the menopausal stage, the mineralization of the bone decreases, the bone density decreases and results in osteoporosis. So, if you are consuming a diet which is rich in isoflavones, it is said that it will protect the mineralization of the bones and thereby it will protect you from osteoporosis. These flavonoids also have a good anti-inflammatory activity. They act as anti-diabetic. They have a good ability to control your LDL cholesterol and help especially in your CVS condition, cardiovascular disease condition, as well as gallstones. Because of their isoflavone or anti-inflammatory activity, numerous other effects are also attributed to soybean and soybean extracts. This includes inhibition of angiogenesis, that is vasculature formation, especially on the cancerous cells. Now it also inhibits your tyrosine protein kinase, ribosomal S3 kinase and DNA topoisomerase, especially the mammary 5 alpha reductase, and hence it is known to prevent breast cancers in women. So having a diet which is rich in soy can kind of protect you from breast cancers. Now in males it is also beneficial and it is known to inhibit the male pattern baldness. Consuming soya products has also been proven beneficial, especially in post-menopausal or perimenopausal conditions such as hot flashes. So it controls that, it kind of regulates it, it acts as estrogen mimetic and hence is proven beneficial for you. So all in all, considering diet which is rich in soy, such as soy chunks, soy sauce, or even soy based products such as tofu and milk provides you source of all these compounds and is very beneficial for menopausal women. We now move on to the next drug, and the next drug is milk thistle. Now milk thistle has been used in Ayurveda also, is used in traditional medicines. In fact, it is one of the herb which has been reported to be used as early as 2000 years ago. So what is this? So milk thistle consists of extracts which is generally obtained from the seeds of Silybum marianum. Now this is an Asteraceae family members. It bears numerous flowers. It is native to Europe, but because of its application you will find it cultivated in Asia, America and Australia. Like I said, it is there even in Indian traditional medicine. So it is used for hepatic disorders and it contains compounds which will protect you from that. So what does it contain? It contains a compound or a set of compounds called as silymarin. Now silymarin per se is not a compound. Silymarin is a combination of compounds together which is known as, or together which is clubbed as silymarin. So silymarin is a mixture of silibin, silicristin, isosilibin and silidinin. So let's take silibin. So they are basically flavolignans. So if you see this much part where you put hydroxys group to your 3-4- place. So this is a typical flavonoid nucleus, but in addition to that you have something called as a phenylpropanoid being added to it. So if you can again configure it. This is the phenyl and this is 1, 2, 3 propane. So you have a phenylpropane, and when you have two phenylpropane you kind of call it as flavolignan derivatives. Now this flavolignan derivatives, depending upon their isomerism, you can call this, now this is silibin A, just change the isomerism, bring this bond ahead of the plane and send this behind the plane, you will get your silibin B. Now just change this, instead of this bond being behind the plane, if this comes ahead of the plane, it is called as isosilibin. And similarly you have the other isomers coming in. You will have silicristin and silidinin, which are slightly differing in their ring arrangements, but all in all they possess the central moiety which is same. So these compounds were initially difficult to separate. So as a result the researchers put them all together, and structurally since they are very close to each other, they were together clubbed as silymarin. So silymarin is a mixture of silibin, isosilibin, silicristin and silidinin. Apart from it, your thistle also contains tocopherols and fatty acids. Now because this has been extracted from seeds, they are rich in fish oil and tocopherols, which also make up a good component of the extract. Now where do you use this? From traditional medicine, you will see that it has lot of hepatic benefits. So milk thistle is used for liver disorders such as cirrhosis, hepatitis. So if it chiefly targets your liver and gives you very protective and healing effect on your liver. So many of the liver disorders are cured by this, including cirrhosis, hepatitis, your toxin induced liver damage. In fact, it is even given for people having alcohol induced liver damage. Now this drug, that is your silymarin, let's put it together. It acts by inhibiting the binding of proteins or binding of toxins or binding of any haptens, we call it, to the liver cell receptors. It decreases the oxidative stress. Now this is basically because of its detoxifying effect, antioxidant effect. At the same time, we have in our body natural antioxidants, and these are like your glutathione. So it will enhance the level of glutathione, thereby increasing or stimulating more antioxidant effects. It also increases protein synthesis, and as a result more and more good cells have been generated, good proteins have been generated, and that's why your liver cells regenerate very fast. So like I said, it has good healing as well as antioxidant effect. It is also used nowadays and prescribed to a little extent in treatment of fatty liver disease. So when you're looking for a liver protective effect, this is a herb or this is a go-to herb in traditional medicine. The next example we do of your flavonoid containing drug is a simple grape peel. Now when you consume grapes, you must have seen that there are different variants of grapes, right from what you call it as the green grapes to red, purple or even black color. Now the most dark grapes are the Concord grapes, which have been put in the image here. All of this have been obtained from Vitis vinifera and many other species of Vitis, probably by hybridization, probably by cultivation, and belong to the family Vitaceae. They all kind of tendril producing aggressively growing plants, and they require a good cultivation practice in order to ensure that the yield is good. Now in terms of their produce, China is the leading producer of grapes, followed by Italy, Spain, France, which are the main ones, and in US. So the grapes production is seasonal. It requires temperate climate, but somehow many of the grape species have adopted to tropical conditions as well. Now grape needs careful cultivation, trimming, pruning and removal of foliage. So if there are too much leaves and produces shade, the grape yield will be poor. So removal of foliage, removal of canopy, what they call it, or pruning, trimming, or sometimes even grafting is very vital, and at what stage it is done determines the quality of your grapes. Now grapes contain, especially if you see the grape peel, it is one of the richest source of polyphenolic contents. It contains numerous polyphenols, and the most important of them are your anthocyanins. So in your anthocyanins you have malvidin. So you can see here malvidin. Now we discussed previously that anthocyanins carry a flavinium ion. So this is it. In terms of hydroxy substitution, you have a 3, 5 and 7 hydroxy substitution, of which the 3 has glucose attached to it. So it is a malvidin 3 glucoside, and we saw previously that initially if you have a hydroxy group, it gives you more of your red or pink coloration, but as they get substituted more and more by methoxy, you get a purplish coloration. So malvidin is one of the compound which will give you the purplish coloration, and pionidin comes somewhere near to that. So you have malvidin, you have pionidin. Now in some cases what happens is the grapes get infested by fungus, and as a result, in order to defend the fungus, it starts producing compounds. You remember in your first session, I told you about compounds called as phytoalexins. Phytoalexins are something like your antibiotics. So these compounds have been synthesized instead of microbes. This kind of compounds are synthesized by plants. So they are not called antibiotics, they are called as phytoalexins. So they are synthesized by plants to ward off. So chemically if you see, they are phenols. So you might have seen antimicrobial compounds like your cresol, resorcinol, and you know that because they carry this polyphenolic groups, they are toxic to the bacteria. So same way, resveratrol is a polyphenol, but it's attached by a stilbenoid kind of nucleus, and the stilbenoid nucleus is beneficial to us in a numerous ways. So resveratrol is one of a polyphenolic compound which has been approved in therapy for cancers as a prophylactic as well as a supportive treatment. Apart from that, it contains other flavonols, it contains your tannins such as catechin, epicatechin, as well as they are gallate esters. It contains cinnamic acid derivatives. Now all of this, you know that sugar content of grapes is very high, and as a result the rate of infestation is very high in that. To prevent that, your grapes produces lots of this phenolic compounds, and that is the reason your grape peel is so rich in polyphenol. So it also contains defensive compounds like caffeic acid, ferulic acid, coumaric acid, and so on. Now because it contains so many polyphenols and so many anthocyanins and flavanol derivatives, tannin derivatives, it is very high when it comes to its antioxidant capacity. So grape peel powder is a strong antioxidant. Now because of the anthocyanin content, you will see that nowadays there is a need for natural colorants. People don't want synthetic colors to be added in their food. So if you're thinking of a color like a black currant or a purplish hue that you want, this grape anthocyanins are readily water soluble. So they are water soluble pigments. In ice creams, we need not worry about the pH, and ice creams are often stored at colder temperature. So they are good stability. So especially your grape peel powder, you will find it in frozen foods, yogurts and cheeses. In some cases, there are applications where your baked goods such as cakes and pastas are also using it, but that's basically to improve its nutritional profile. When you take your grape peel, apart from the pigment, apart from the polyphenol, you will see that it is rich in fibers. It is the skin, so it will contain your cellulose and lot of other fibers. So adding grape peel to your pasta or to your cakes make them fiber rich, and that potentially the polyphenols in that also act as antimicrobial agents. The anthocyanins deteriorate, the other polyphenols do not, and as a result they have a good antibacterial effect, and potentially the shelf life of this compound is improved. Now because of its other antioxidant effects and the compounds present, it is known to enhance a good longevity in people by its antioxidant, or what you call it as free radical scavenging effect. It is known to manage, or it can be used in managing metabolic syndromes, improved vascular function, improved circulation, as well as reducing inflammation which is there in body. So these are few examples of flavonoids in this session. Here are few references if you wish to know more about these compounds. Thank you everyone.